Hello, friends. Welcome to another topic of arithmetic that is very relevant for your exams like CAT and MAT or any other MBA entrance exam. So, if you see, arithmetic itself has a very high weightage in terms of the number of questions that come in CAT or any other MBA entrance exam. By within arithmetic also, time, speed, distance, or TSD, as we commonly know, has a very high significance. So if you get around 10 questions out of arithmetic, you can be sure of two to three, sometime three, otherwise two questions from time, speed, distance you can expect in hand. So it's a very concept heavy area. So problems are may not be difficult or unsolvable kind of problems that can come. Problems that can come in CAT or ZAT or in MAT is basically where they will check your conceptual clarity since and the application of it. So there are hardly any formulas for you to remember here, like let's say a simple interest, compound interest piece where you need to know some of the formulas. The idea here is to focus on the concepts and get that conceptual clarity. Otherwise, time, speed, distance problem may appear to you as a difficult one if your conceptual clarity is not there in place. So what we'll do, like the other sections, we will cover the basics in this session. The next session on time, speed, distance will cover the fundamentals of time, speed, distance, fundamental problems from time, speed, distance, where we see the basics that we learn. We will apply some of those basics to solve few of the problems. And the third session on time, speed, distance, where we will cover the topics, advanced level problems or level 2, level 3 type of problem. So that's how we cover most of the topics, like we did in time and work. We did basics, then we did foundational level problem, and then the advanced level problem. So in each topic, we spent 3 sessions to completely cover that topic. So today's session on time, speed, distance is the first session of time, speed, distance. We will basically focus on the fundamentals of time, speed, distance. So if we have to see fundamentals, so I will list down the topics that can come under fundamentals and we will talk each one of them. So first is basically the definitions, or basically the elements of time, speed, distance. Then we will learn about the ratio or variations, I will say, of how they are internally related, like time, speed, distance, how they are internally related. Then we will do something like average speed. So these are the topics that we are going to cover into this session. Then we are going to talk about relative speed. So then we see applications around trains and boats. Trains, boats, and to some extent we'll do escalators. So these are all the applications of time, speed, distance. And we will see there are certain nuances for each of these. So that's why we are taking these applications separately. And then we will typically do the race, or basically your linear race plus circular race. And then finally, we'll do some part of this, we'll do on clocks. Very basic understanding on clocks, not too complex of a thing. So these are the few things that we are going to cover in time, speed, and distance. And each of the topics I will basically spend some time explain what are the concepts, how you should think about it, and then how, and we'll take a probably a working example and just to make your understanding more strengthened around this area. So with this, let's get started. Just let me have a look if I have missed any topic. No, mostly I'm fine. So let's get started. So these are the 9 areas that we are going to cover today. So let's start with the first one. So the first one is the definitions. So what do we cover in definitions? So most of you know, and this is one of the topic that you are kind of doing from your school days, but some of you may have easy time doing it. Some of you may have a hard time, but forget about all that. Let's start afresh and let's see what are the 3 elements. So when we say time, speed, distance, there are 3 elements to it. One is time, one is speed, and the third one is distance, right? So let's say I am traveling for 1 hour and I started from point A, or I'm going to point B. I'm traveling for almost 1 hour. So, and at a speed of, let's say, I'm just walking. So my speed, let's say 5 km/h. This is your walking speed. So you have a speed. So this component is basically speed. This component is basically your time, how much time you are walking. Then the distance between A to B, or this is it, what you need to calculate. So how we normally calculate? We normally know distance is basically speed into time. So in my case, this speed is 5 and I have traveled for 1. So that means I have covered 5 kilometers. Be a little careful because sometimes they give you speed in different unit and time in different units, so you possibly standardize them. We'll see some of the quick things to standardize them and what are the common different units that can come in a problem. But before that, just to be sure of, because here we are talking about km/h and here we are talking about hours, so they are already standardized. So okay, coming back to distance is basically speed into time. So we have covered, this is one formula we know, distance equal to speed into time, where we are saying time is t, speed is s, and distance is d. This is the most common formula that has been used between speed, time, and distance. So that's what it talks about. Speed is always what is the what is per hour speed, what can be per second speed, what can be per minute speed. So the speed can have how much distance you cover in per minute. So basically, if I have to calculate speed and I know the distance I have covered and the time I have taken to cover the distance, I'll be able to divide the distance with the time to get the speed. And similarly, if I have to calculate the time, it's basically how much distance I have covered and what is my speed. So let's say I have covered 5 kilometer and I am moving at a speed of 5 km/h. So I need 1 hour to finish it. So these are the, basically this is the one formula and these are the derivations of it. So that's the basic point of time and work. Very fundamental thing, how much time you have traveled, how much time you have taken to move from one point to another. What is the distance between that 2 points? What are the distance between those two destinations? And what is your speed? Now you might think in a real world scenario, speed may vary because you cannot continuously walk for 5 km. You may walk for 5 km/h in 2 minutes, and then for the next 2 minutes you cover say 4 km/h. But for standardization's sake, and in this type of problem, we normally, unless specifically mentioned in a problem, we normally consider the person or the car or whatever it is moving at the standard uniform speed of that speed that is given. So in this case, we have convert that 5 km/h speed is uniform for 1 hour. Okay, so that's about it. So this is the definitions. Now let's go to the variations or ratios. You can say variations because variations is basically the thing that we are going to learn. So let's say I'm sitting in Kolkata. So I am sitting in Kolkata and I have to get into a train to reach Delhi. So there are these 2 points, these 2 states, these 2 places in India, and then I need to board a train, right? I need to board a train. So what happens? Let's say what is fixed between Kolkata and Delhi? In the fixed between Kolkata and Delhi. So there are 3 entities: distance, speed, and time. So what is fixed here between Kolkata and Delhi? The distance is fixed. So I know my distance between Kolkata and Delhi will not change. Either I go by train or I go by car or I go by bus or I go by flight. The distance will never change between Kolkata and Delhi. So my distance is fixed. Okay. Now let's say I'm going by a train. Train will have a train versus I'm going in a car. So what will change? So let's say for a train, my speed will be higher versus for a car, my speed will be lesser. So what will happen if I go in a train? I will take time much lesser versus if I go in a car, I will take a much higher time. So if I can put in an equation, so I can say if distance is fixed, then if your speed is more, your time will be less, because for train, the speed is more, it is taking lesser time. For car, the speed is less, so it is taking more time. So can I say speed is inversely proportional to time? A very, very important concept, which you may feel now it's very obvious, but there's a very powerful concepts that we are learning now, which will be applicable to a lot of problems once we start solving those problems. But learn that distance is fixed, speed is inversely proportional to the time. Similarly, let's say the same kind of a problem where we are saying the train and the car. Now, don't consider Kolkata to Delhi where the distance is fixed. Let's say the train moves for 1 hour and the car also moves for 1 hour. So let's say the train is moving for 1 hour and the car also is moving for 1 hour. So obviously my time is fixed now. If my time is fixed, again, so if time is fixed, then speed will be proportional to the distance, because train will cover more distance because train has a higher speed, right? Similarly, we can say, so if the speed increases, the distance will increase. If you cover moving at, let's say 50 kilometer per hour, in 1 hour you will cover 50 kilometer. If you are moving at 100 kilometer per hour, in 1 hour you will cover 100 kilometers. So your distance will increase if your speed is increasing. Similarly, if your speed is fixed, so let's say you move in an absolute fixed speed. So if you give more time, you will cover more distance. So distance is proportional to time. Very powerful three relation, which you can understand that when the distance is fixed, speed is proportional to time, inversely proportional to time. When time is fixed, speed is proportional to distance. When speed is fixed, distance is proportional to time. So a very powerful one. Let's take a working example and just let's say I will show you how powerfully we can apply this. So let's say there is a person, this is the person's house, and let's say this is his office, right? The person drives a car, let's say 20 kilometer per hour, drives a car 20 kilometer per hour. Okay. Or let's say this is not given. Let's say this is not given. So just let me see the problem once. So let's say there is a person in his house and office. So let's say the person normally goes from house to office. One day, the person has increased his speed by 25%. So one day, what is his normal speed? He has increased the speed by 25%. And because of that, he reaches office and say 15 minutes early. He reaches the office 15 minutes early because he has increased his speed by 25%. Can you now tell what is the normal time it takes? So basically, if you have increased your speed by 25%, you have reached the office 15 minutes early. Now, we have seen two ways. So first, let's say the distance between office and house is, let's say D. So D, his normal speed is S, and he, let's say, takes T times. So we have to find this value T, but let's say this is one equation. The other equation, we know the distance will remain constant. So the distances remain constant. Your speed has increased by 25%. So 1.25 s, and t is reduced by 15 minutes. So this is t minus 15, right? Let's say he takes t minutes earlier. Now he is taking t minus 15 minutes. So I can easily calculate this as t 1.25 s t minus 15. If I do s gets cancelled. So t is 1.25 t minus 18.75. If you just exchange the side, 0.25 t is 18.75. So then t is 18.75 into 4. 75 minutes. So his normal time is 75 minutes. If he increase his speed by 25%, he will take possibly 60 minutes. So this is one way if you try to do this from an equation method. Now, if you understand this concept well of a variation, how this varies. So here distance is fixed. So let's see, I will show you in a different way. So this, what we did in the first learning that we did, d equal to st, we just applied that. Here we are applying the variation concept. So distance is fixed. If the distance is fixed, so I know speed is inversely proportional to the time, right? So if your speed is increased by 25%, that means if your speed was s before, now it is 5s by 4. How I get 5s by 4? Because it's s plus s by 4. S by 4 is nothing but your 25% increase in speed. So if your speed was s, now your speed is 5s by 4. So if your speed changes to 5s by 4, if your time was t before, now you should take 4t by 5, which is, because speed and time is inversely proportional. If you take 5/4, if you increase your speed to 5/4 of the actual one, your time will reduce to the 4/5 of the actual one, right? So the t to 40 minus 5. So basically, how much time you are saving? So you are saving t minus 40 by 5 or t by 5, right? This is your saving. Can I say this t by 5 is nothing but the 15 minutes you save? So that means t is 75 minutes. Whichever whichever makes you comfortable, you can use it. But at certain time, understanding this is basically shows your conceptual clarity, and try to use this, and then this kind of problem becomes much faster and much more easier to calculate when you are using the variation or using your concepts of variation between speed, time, when one distance is fixed. The left-hand side approach is, if you are not clicking this, the variation approach is not clicking in your mind, you can use the left-hand one and basically then calculate right away is by just forming the equation and go ahead and solve the problem. If the numbers are difficult, if there are too many other variations, it may be a little complex to calculate the equations on the left-hand side, left side approach, but it will give you the answer. So whichever way you are comfortable, you can use it. I just taught two different concepts of time, speed, distance. One is the basic equation, other is the variation. They solve the problem with both the approaches. Let's move on. The next concept is on average speed, which is a very important concept, average speed. So let's say I go from my house to office. Let's say the distance between my house to office is, let's say, let's say this distance is 60 kilometers. Okay. While going, I leave early. So let's say I leave at 7 a.m. kind of a thing. And while going, I go at a 50 kilometer per hour speed. Or yeah, 50 kilometer per hour speed. While coming back, there are more traffics, and I came back at a 30 kilometer per hour speed. can you tell me what is my average speed? So average speed, normally if you think the average speed is the average of 50 while going and 30 while coming back, and the average of that, which is 40 kilometer per hour, this is not the right one. So basically your average speed, it's the calculation is total distance, right? Total time, right? So total distance, I have gone 60 kilometer and came back 60 kilometers. So 60 plus 60 is 120. Total time while going, it should take 60 by 50 minutes. And while coming back, it should take 60 by 30 minutes. Or you can say this is 120. This is 1.2. And then this is 2. So 120 divided by 3.2. Or we can say this is 120 divided by 32 into 10. Just do this. So 8, 30. And even I can do with, so this is 300 by 8. And 37.5 kilometer per hour, which is not same as 40 kilometer per hour. So this is basically the average speed. So average speed, only thing you should remember is total distance by total time. If I consider this as, let's say just generalize this. So let's say you have gone S distance and come back S distance. While going your speed is, let's say, A kilometer per hour, and while coming back it's B kilometer per hour. So it should be S by A total time plus S by B. So if you see, this is 2S and S into 1 by A plus 1 by B. So A2 divided by 1 by A plus 1 by B, or 2AB by A plus B. So what is the important thing here is, you need to understand, while calculating average speed, the distance does not matter, right? If you see this equation, your A and B is your going speed and coming back speed. So 2AB by A plus B only can give you the average speed. So whatever be your distance does not matter. You just need to know the individual speeds, and then from that only you can calculate the average speeds. Very important thing need to remember when problems come around data sufficiency. They may give you the speed distance somewhere, but that's not the information you need mandatorily. It's a nice to have information, you can use that, but that will get cancelled out, and basically you don't, that's not a must have kind of information you need while you are calculating average speed. It's 2 into going speed into coming back speed divided by going speed plus coming back speed. In this case it's AB by A plus B, 2AB into by A plus B. A very basic one for average speed. Let's move to the next topic, which is on the relative speed. So if we talk about relative speed, it's a very, very important concept. So there are a few variations to relative speed. So relative speed is basically when you are moving. Let's say you were sitting in a train, and all of us experienced, childhood, and that was a kind of a surprise to us when we are moving in a train. We used to see the trees and the houses are moving in the opposite direction. It feels like we are just standing at sitting in a certain place, and the houses and trees are moving in the opposite direction. But that's not the case actually, right? So what happens if you are sitting in a moving object? The other stationary objects seem to move in the opposite side, or that's how it feels. Or sometimes if you have realized when you were sitting in a train and then there is another train coming from the opposite side, suddenly you feel that the speed has increased, the way the other train is crossing you, because the other train has its own speed and you have your own, the train that you are sitting in has its own speed. So both of them kind of cross each other, but you have suddenly seen that the train is moving very fast, but that's not actually the case. So that's the relative concept of speed. So basically what happens when there are two objects, so let's say the first part. So one object is moving this side And then there is another object which is also moving in the same side. So this object, let's say speed is A, and this object, let's say speed is B. So in this case, your relative speed is basically A plus B, right? Just see about the unit should be same for both of them. But let's say if you move in this side and then there is another train coming from this side, sorry. But so the previous case, this is A minus B, considering A is greater than B. So A will overtake B with the relative speed of A minus B. So here the relative speed is A plus B, where both of them are coming from opposite side and crossing each other. The speed suddenly seems have increased because both the relative speed is the sum of both of them. That's why the speed has increased. Let's say, and we will see some of the train concepts here also. So let's say there is a train. Let's say there is a train moving, and then there is a pole, or let's say there is a tree. So obviously, when a train crossing a stationary object, so there are two kinds of stationary objects. So let's say the train is moving a kilometer per hour. Let's say the length of the train is L. So in this time, obviously, the stationary object or the tree or this pole does not have any speed. So they are stationary, and their length also is very negligent when compared to the length of the train. So time needed to cross is nothing but L by A, or we can say length of train by relative speed. Now relative speed here is nothing different than the speed of the train, because the other object is stationary. So even if you are crossing it, since the other object does not have any speed, the relative speed is nothing but the same speed as the train speed. But it has to cross its own length. So completely cross the pole or the tree, the time needs, the time the train needs is basically length of the train, which is the distance it has to cover, divided by the relative speed. Now the other variation of this is, let's say a train is moving, and let's say there is a platform, and let's say the platform's length is small l. So this is a platform. Now this is no more a stationary object. It's still a stationary object, but no more a stationary object whom speed you can whose distance or whose length you can't anymore ignore, like a tree or a pole whose length you can ignore, but a platform's length you can't ignore. So in this case, the time needed will be L plus L, because that's the total distance. The train has to cover its own distance plus the platform's distance divided by A. So here we can see L plus L divided by A. This is the time taken to cover the cross the platform completely. Similarly, if we see a train crossing another train, so let's say this length is L, and this length is L1, and this length is L2. Speed is A and speed is B. Obviously L1, while a train has higher speed, then only it can cover coming from behind the L2 while train. So A is greater than B. So in that case, the time needed to cross is L1 plus L2, because that's the distance it anyway has to cover, own length plus the train ahead, that length. But now it's a relative speed because both of them has its own speed. No, one of them is no more stationary, both of them are moving, so it has to be A minus B. Similarly, if a train is coming from this side and the other train is coming from this side with a length of L2, A is B speed, now the same speed will be L1 plus L2 by A plus B, because this is now your relative speed, because both of them are moving in the opposite direction and crossing each other. Sometimes they may tell you a train and a car If the length of the car is not given, you can consider that that length can be ignored. If the length of the car is given, you can consider the length. Otherwise, it's basically the train's length and the relative speed. The relative speed will be there because if a car is moving, it will have its own speed. So that's a very simple kind of a problem, but you need to understand these concepts well. Okay. Now, the next part that we are going to cover is around boats. We have already covered the train in the relative speed section. Boats, it works very similar, but there are certain nuances of boats. So when a boat is moving, so boat has a speed of the boat. It's considered as the speed. When we say the boat speed in still water. But we know water has its own the wave. So just a minute. So this there is a wave, and they have its own speed, right? So the wave speed, let's say v km/h, and then there is a boat on top of this. The boat has two options: either move towards the speed, it can go like this, or it can come like this. So either you're going with the stream or with the flow, the direction that stream is flowing, that is called as upstream. Or the other option is boat is going against the stream, which is called as downstream. So if the boat speed is, let's say, a km/h, so the upstream speed just give me a minute. Okay, sorry, so there was one change. That's what I just referred. So when the boat is moving with the stream, it's called downstream. When it's moving against the stream, it's called upstream. So it basically upstream is this, and downstream is this. So basically, when the boat is moving with the stream, it's called downstream. When the boat is moving against the stream, it's called upstream. So upstream speed is basically when the water opposes the boat. So that means it should be a minus b km/h, or a minus b. A has to be more because otherwise the boat will not move forward, because if the speed of the stream is high, the current of the stream is high, it will not allow the boat to move. So considering the boat will move front, boat has to have the speed which is more than the stream speed, but the stream is opposing the boat while moving upstream, so it should be a minus b km/h. Similarly, for downstream speed, it has to be a plus b km/h, because now when the boat is going downstream or with the stream, it is basically going with the flow. That means the water current is actually helping the boat to move front. So that's how it is. So if sometime in a typical set of problem, the boat speed is a km/h and the upstream speed is then a minus b, where b is the speed of the river, but a is basically, always remember, a is the speed of the boat in the still water. It's not the speed of the boat whether moving upstream or downstream. If the river is completely still, there is no flow in the river, there is no current in the river, then the boat speed is a. So that's the natural speed of the boat. But sometime you may see that the boat speed is not directly given to you. They will give you upstream speed. So they will give you upstream speed, let's say u, upstream speed. So both upstream speed, they will give you both downstream speed they will give you. So basically they may tell you boat's upstream speed is u, which is nothing but in the previous case is a minus b, and boat's downstream speed is b, which is in the previous case is a plus b. Then they say what is the boat speed in still water. So they might ask you what is the boat speed in still water. So if you know the upstream speed and downstream speed, then the boat speed in still water has to be u plus b by 2, or upstream plus downstream speed by 2. Similarly, stream speed, in this case is u minus b by 2, or basically if you know u equal to a minus b and v equal to a plus b, how you calculate a and b. So that's what it is. You can just add u plus b and then you will get 2a, and that means u plus b by 2 is equal to a. A is nothing but boat speed in still water system. Just a tweak, they might tell you upstream and downstream speed instead of telling you the individual speed and ask you to find out the individual speeds. So you can directly add upstream plus downstream and divide by 2 to get the speed of the boat in the still water, and minus and divide by 2 if you want to know the speed of the stream. So that's about boats. Okay. Now there is also another problem around skeleton, which is kind of same. We'll see some of the problem around skeleton, but what happens in a skeleton is, let's say you are standing here and the skeleton is continuously giving you steps to move upwards. So when it's the same way, so when if you are going up and you are just standing in the skeleton, you are moving at the skeleton speed. So if you are still standing, you are moving speed of skeleton. So if you are moving at the speed of skeleton. So the normal speed of skeleton is, let's say, they say 4 steps per second, something like this. 4 steps means there are, in 1 second, there are 4 steps coming out of the skeleton, and if you are just standing in a second, you will move 4 steps. But if you have your own speed and you are moving upwards in a skeleton which is also moving upwards, then your own speed plus skeleton speed. But if you are moving in a, let's say a skeleton is moving up, and but you are standing here and you want to come down, so in that case your own speed minus skeleton speed. It's not necessarily that your speed will always be more than skeleton speed. It is possible that your speed is less. Then in that case you will not be able to reach to the bottom anytime, because if you are coming down 1 step and skeleton speed is 2 steps per second and your speed is 1 step per second, if you take 1 step, skeleton is push you up 2 steps. When you take 1 step, skeleton will push you up 2 steps, so you will not be able to come down. So but let's say the total distance between the, let's say this is first floor and let's say this is 4th floor, I'm just saying, and let's say there are 100 steps, right? And you are standing here, you are also moving, there is skeleton is moving, you are also moving. Let's say skeleton speed is 5 steps per second and your speed is, let's say, 15 steps per second, same 15 steps per second. So together, if you are moving up in an upward moving skeleton from 1st floor to 4th floor, your relative speed is 15 plus 5, 20 steps per second, and you will need 5 seconds to cover all the 100 steps, or from 1st floor to 4th floor. So that's how the skeleton problems are. So just different variations. So if you see train, if you see boats, if you see skeleton, it's all variations of a or application, not variations, the applications of relative speed, which is a very important concept when it comes to time, speed and distance. Now coming to the last 2 part of the time, speed, distance, which is race. Now race, the linear race, you know, we have already covered in kind of a train problem, where if let's say this is a guy who is moving this side and this is another guy who is moving also this side, then if his speed is a, his speed is b, then your relative speed is a minus b. Or normally they say how many times or what is the time that one person will finish the race versus who will win the race, kind of a problem. So let's say, and there is a 100-meter race, and let's say this is a guy who is standing here, a b, and there is a guy standing here, let's say Ram is standing here, but Ram's speed is, let's say, 10 kilometer per hour. So 100-kilometer car race, let's say Ram's car moves 10 kilometer per hour, and let's say Sham's car moves 15 kilometer per hour. So obviously, or let's say for ease of problem, let's say 20 kilometer per hour. So Sham will take 5 hours to finish the race. Ram will take 10 hours to finish the race. So Sham obviously wins. So basically that's the difference. Different nuances will be there for a race kind of a problem, in a linear race kind of a problem. What will also happen is there are two things needs to remember. There are statements like let's say Ram has head start. This is a statement, and I just want to familiar you with the phrase Ram has head start of 1 kilometer. That means when Sham starts, Ram is already 1 kilometer ahead of the game, ahead in the race. So let's say if Sham starts from here, Ram is already standing here, which is 1 kilometer ahead. And then obviously Sham's speed is 10 kilometer more. So then to cover that 1 kilometer distance between Ram, he possibly needs 1/10 of the time. That's how it is. But just to understand, head start means the other person is 1 kilometer ahead, or that many meter or kilometer ahead of the person who is just starting. Also, there is also a statement like, let's say Ram has been beaten by Sham by 10 meter. 10 meter. So that means when Sham finishes the race, Ram is 10 meter behind. Ram has been beaten by Sham, or Sham finishes the race 10 meter ahead of Ram, something like that. So that these are just the two phrases you should be remembering. It is a person has a head start in terms of kilometer, or a person has beaten by this many meter, means when that person has finishes the race, the other person is 10 meter behind, or that many distance meter or kilometer behind from the end point. So these are the two things you need to remember. The important part of race is when we do a circular track, which is a very important part. The circular track, there are two things that happens. So let's say this is the, let's say it's a circular track, right? So let's say it's A, and let's say B. So for the matter, let's say A is also moving this side, B is also moving this side, right? So let's say the length of the circular track, I'm just saying length of the circular track is, let's say 100 meter. A is moving 10 meter per second speed. B is moving 20 meter per second speed. So again, coming back to the starting point. So when a circular track race finishes, if you start from here, you go completely and come back here, right? At the starting point. So A takes how much time? A take 100 by 10 second. B takes 100 by 20, 5 second. So if they are moving in the same direction, then A will come back to the starting point after every 10 seconds. B will come back to the starting point after every 5 seconds. So can I say both of them will meet at the start point after every 10 seconds? So why 10 seconds? Because after every 10 seconds, A is coming to the starting point and B is anyway coming after every 5 seconds. So 5 seconds per B is here at the start point, but A may not be there. Again, 5 seconds per B will be here at the starting point after another 5 seconds. So now A will be here. So after every 5 plus 10 seconds, B will anyway be there at the starting point, and after every 10 seconds, A will be there at the starting point. So after every 10 seconds, they will keep meeting at the starting point. And so that means one pace. The other one is when A will overtake B. So let's say both of them start from here, and A is moving this side, B is also moving this side. When A has a lesser speed, so when I will say B will overtake A. So this is also a relative speed kind of a problem. So if you think conceptually, B is moving this side, A is moving this side. So let's say both starts from here. Now B has gone ahead, A is left behind. So B will again cover A when B's total distance covered. B has covered one more round more than A. So this is how to attract, right? So I will be able to overtake a person whom I just crossed or whom I just started with. I'll be able to overtake that person when I cover one round extra of that person. So let's say the other person, so let's say A has gone from here to here, and by that time B has already covered this much and again come back here. So basically A has just gone this much, B has covered this much, so anyway, but one more round than this much. So basically when the faster person covers one round more than the other slower person, that's the time the faster person will overtake that person again, or that's the will meet that person again, which is different from the starting point meeting. So there is two meeting happening. One is at the starting point, other is when the faster person crossing the slower person. The faster person will cross the slower person every time. The faster person will cover one round more than the first person. So what we do? B covers one extra round. So one extra round means 100-meter B has to cover, and one extra round means 100-meter. Now it has to be relative speed, because every second B is covering 10-meter more. So how come you get the 10-meter? 20 minus 10. That's the relative speed, because every time B is covering 10, 20-meter, A is also moving up by 10 meters. So B's gain in every second is 10-meter only. Now that gain has to be 100 meters so that B will be able to cover one more round. So that means 10 seconds. So after every 10 seconds, B will be covering it. Unfortunately, or fortunately, say this crossing is only happening at the starting point, but if the numbers are different, you will see the meeting points will also be different. It may not be always at the starting point, it may be starting point or somewhere else. What will change if A and B moves in the opposite direction? What will change when A and B in the opposite direction? Then A and B will meet together when they together cover 100 meter, right? So let's say what will change if, let's say, A is moving this side, B is moving this side. This is 10 meter per second. This is 20 meter per second, right? So the other thing will remain same, right? So if A takes 10 seconds to finish and B take 5 seconds to finish, they will meet at the starting point again at every 10 seconds, because it does not matter from which side you are coming to the starting point. You are coming to the starting point, that's what matters. And you will meet at the starting point only at, that does not change which direction you are coming from. So A will take, and after every 10 seconds, A will come here. And once B starts, B after 5 seconds, B will be here, but A will not be here till then. Again, after 5 seconds, B will be here. Sorry. Again, after 5 seconds, B will be here. That time A will be here. So B will be coming from this side, A will come from this side, but after every 10 seconds, they will keep meeting at the starting point. Similarly, But this will change when A has to, but the thing that will change is meet or overtaking. Overtaking to will not kind of happen because both of them are kind of moving in the opposite direction. So meeting is, so 100 meter, both of them opposite direction. So in 1 second, they are actually covering 20 plus 10, 30. So they will meet, if they are moving in the opposite direction, they will meet when they together cover 100 meter, right? So when the entire peripheral length will be covered by both of them together, that's when they will meet. So this will be relative speed is A plus B. Same when relative speed when two things are moving in the opposite direction. So 100 by 30, you will typically get 3.33 second, right? So then one important thing you just need to remember, one table is very important table, moving same direction versus moving opposite direction. Now you need to know in same direction versus moving the direction, time taken to meet at start point. And then, so this is a table you need to remember, which is very useful table. Time taken to meet at the start point. Time taken to cross or overtake, which can be different from the start point. So if this is the case, then you can remember this table. So if you have created this, but you also need to remember time taken, like I said, it has to be the first time meeting. So first time meeting, otherwise it will be a multiple of that. So if you remember what we did is the first time meeting is the person who is moving, let's say same direction. If you're moving in the same direction, when you will meet, it will be the LCM of individual time taken. So previously we have seen that individually A takes 10 seconds and B take 5 seconds. It's LCM of 5 and 10, which is basically giving you 10 seconds when they will meet at the start point for the first time. 10 seconds the first time, 20 is the second, 30 is the third. That's how they will move, right? So that's the LCM of by A by B. But time taken to cross each other, it will be A minus B because they are moving in the same direction. When A will overtake, B will overtake A, when B will do a one round extra. And for that one round extra, it has to consider the relative speed. Same we have done in the previous scenario. But when you are moving in the opposite direction, then time taken to meet at the starting point, when you again meet at the starting point, it will remain same. It will be LCM of L by A, comma, L by B. It's the same. But here it will be L by B. Sorry for the confusion. So I think this is what we have done earlier, and this is what it is. Also, one more important thing for you need to remember is when there is a race kind of circular kind of a racetrack, so number of meeting points. So like I said, in the previous example, the meeting point was always on the center, or always on the starting point, not the center, always on the starting point when they are moving in the same direction. But if you see in the opposite direction moving, there may be multiple meeting points. Or also, if the numbers are different, you will see when they are moving in the same direction also, there may be more than one number of meeting points apart from the starting point. So number of meeting points when in same direction, it has to be A minus B numbers. Or opposite direction, I'll take an example. Opposite direction has to be A plus B numbers. Remember, this is A minus B when speed is A is to B in the most simple form. What do I mean by most simple form? So let's say A speed is 25 kilometer per hour and B speed is, let's say, 10 kilometer per hour. So the speed ratio is 25 is to 15, or we have to take it in the most simplest form. The simplest form is 5 is to 3, not 25 is to 5. So when A and B moving in the same direction, the number of meeting point will be 5 minus 3, 2 numbers. When they're moving in the opposite direction, the number of meeting points will be 5 plus 3, or 8 numbers. So there are 8 meeting points. This is there are 2 meeting points when they're moving in the same direction. That will include the, and this will take care of the meeting point at the start. So apart from when they're moving in the same direction, there are 2 number of meeting points, which is 5 minus 3, 2. One of them is the starting point, other is somewhere else, right? Okay, so that's about the race and track. And finally, clocks. In clocks, you don't need to remember much, but if you typically see, there are 3 hands in a clock. One is the second hand, one is the minute hand, and that is the hour hand. So if I see a second hand clock, then can I say in 1 minute the second hand clock completes a full degree? So can I say it covers 360 degree in 1 minute, or it is actually covering 360 degree in 1 second, right? So let's say the hour hand. See if this is correct or not. Think on this. I'll come back to this. If you think hour hand, it covers the 360 degree in 12 hours, right? So 360 degree in 12 hours. So if I see a minute hand for a minute, it covers 360 degree, right? A minute hand, it covers 360 degree in 1 minute. So basically, if there is a clock, you have a minute hand, you have a hour hand. So is it cover 360 degree in 1 minute? No. Minute hand is the smaller one. Oh, sorry, hour hand is the smaller one. It takes 12 hours to finish it. Similarly, if I take a minute hand is a bigger one. So it will be 1, 2, 3 like this. It will take 60 minutes. So 360 degree in 60 minutes. 360 degree in 1 minute, right? So this was actually correct. The second hand, in 1 minute it covers 360 degree. Minute hand 360 degree covers in 60 minutes. Hour hand 360 degree covers in 12 hours. So if I just standardize everything, so for second hand 360 degree per minute. For minute hand, can I say 6 degree per minute, 360 degree in 60 minutes. So 6 degree per minute. For hour hand, 360 degree in 12 hours. So in 1 hour, it will cover 30 degree, right? Between one mark to other mark. So if we have a clock, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, and just write 4, 5, 6, 7, 8, 9, 10, 11, 12. So between 1 to 2, it's 30 degree, because then the 12 marks is 360 degree. There are 12 gaps. So 30 degree is covered in 1 hour. So it will cover half degree. So this is, now it is nothing different than a circular track kind of a race. You know the speeds. Speeds are 360 degree per minute, 6 degree per minute, half degree per minute, and then it's nothing but a circular track kind of a problem. They will say what is the difference when a minute hand will again cross the hour hand after how many times? Let's say at 3 o'clock the angle is 90 degree. So if I say 3 o'clock, the angle is 90 degree. Again, when the angle will become 90 degree. So angle will become 90 degree when the minute hand and hour hand will again have a difference of 90 degree. So if it is starting now, when it will again have a 90-degree difference. So it will first 90 degrees, so the minute hand will cover, it will cross the hour hand and then again go. So it will first 90 to 0 and 0 to 90 again. So you have to see how and when we will see some of these problems, but it's nothing but a circular track with all of the things moving in the same direction you have to consider. And everything here will be in terms of degree, not in terms of any meter, second, or some meter or kilometer. It will be in terms of degree. So if I say you also need to know the relative speed. Second hand you will get very less number of time, mostly minute and hour hand. Relative speed between minute and hour hand is 6 minus half maybe, or 11 2 degree per minute. That's the relative speed. So it covers, so the minute hand covers 11 by 2 degree more every minute compared to the hour hand. Similarly, then that's the relative speed. We'll see some of the problem in the next session, and possibly these things much clarified. But what we have covered then, finally, we have covered the clocks. From that, we have covered the circular track, which is a very important one. These are the few things you need to remember. Very few things in time, speed, and distance you need to remember. Is one of them is this circular track. How many times they will meet, what is the time taken to meet at the starting point, what is the time taken to meet at again cross or overtake each other, moving from same or opposite direction. Very much conceptual. You can remember the formula, but it's still very much conceptual. This is again circular track. We have also covered the again, this is also circular track. So we have covered the linear race and what is means by head start, what is meant by beaten by this many meter, this many kilometer, this many seconds. So if someone said Ram has beaten Sham by 2 seconds, that means Ram finishes and Sham takes 2 seconds. So it's not only meter, it can be time also. It can be 2 seconds. So that means Ram has been beaten by Sham by 2 seconds. So that means after Sham reaches the ending point, Ram will take another 2 seconds to reach. We have done escalator kind of a problem, which is an application of relative speed. We have done boats, which is a very important one again. We have done trains and relative speeds together, different scenarios of train crossing a pole, train crossing a platform, both trains coming from opposite, similar sides, all of that. We learned average speed, which is total distance by total time and not the average of the individual speeds. And then we also learned the variations and there are two ways, the fundamentals of relation between distance, speed, and time. So I hope this is a very important and conceptually heavy area. So try to understand these basics. We'll come back in the next session with the fundamental problems of time, speed, and distance. And from there, we will take the advanced level problems in the third session of time, speed, and distance. So, and you can go through the previous sessions that we have covered in time and work. In case you need any one-on-one support with me or any help, please reach out to the given mail ID in the description box. And I will drop the previous session links also in the description box. You will possibly have a look. And don't forget to reach out and feel free anytime. You can drop me a mail. And if you need a one-on-one session with me, we'll plan it out together. Hopefully you have a good session. Have a good day or good night, good time ahead, good preparation ahead for that. See you.